Hello, I'm Rod Shaw and welcome to this Heritage Open Days event. I'm involved with a number of other people who put together a programme of events for Heritage Open Days every September. I'm here today in Mickleham, in the heart of the conservation area. Behind me is Mickleham Church, and whilst we normally with Heritage Open Days focus on buildings, because of the hidden nature theme for this year's Heritage Open Days, we'll be looking at something that is a bit different, and I'm waiting for Professor David Hawksworth to join me to talk about lichen on stonework.
Well, churchyards are often places that people think about the dead, but not so much about what's happening in them that's actually alive, because they're very special places for nature conservation, because churchyards tend to get left for centuries without much management, so they can have interesting plants growing in the grassland that you won't, for example, see in the fields nearby. But especially interesting are things that people don't notice very often, and that you notice the coloured patches on the stones, different colours on different stones, but these are all living associations of organisms as well. And these are called lichens, which are basically a fungus which captures bacteria or algae and makes a little characteristic structure. So they're basically a lifestyle of a fungus. And this churchyard is quite interesting in that it has been studied in some detail by people from the Field Studies Council Centre at Juniper Hall nearby over the years. And over 250 lichen species have been found on these stones over the years, and 182 were actually found in the last study just a few years ago. So it's a very rich, so when you actually look at a place like this, it's actually very much alive. And also these things are food for other organisms as well, or camouflage, and there are the moths, psocids, tardigrades and mites all live associated especially with the lichens. So when you look at a churchyard, it's nice and peaceful, but there's also a lot of life going on the stones, and you'll see that the stones have patches in different colours, and the stones are also different as well. And if we look a bit more closely at one stone, you can see there's actually a lot of different colours, patches. We have whites, and we have oranges, and some greys here. All these are in fact different species, and they all have this way of living in that they get their carbohydrates, their sugars, from the photosynthetic activities of either the blue-green algae, or most commonly in this particular case, green algae, which are inside the tissues themselves and they're captured by the fungus. And some of these form continuous patches that grow into the surface, and they actually penetrate the surface. They dissolve the rock and then they convert it chemically from carbonates to oxalates, but some are actually more on the surface and can be scraped off the fingernail if you've got a sharp enough fingernail. And you see these that are making circles, these grow outwardly, and if you think about a fungus on an apple that's gone bad in your fridge, it often will make circular patches, and these grow just in the same way as the fungi that cause food spoilage, except these grow very slowly, because these will only be probably a few millimetres at the most, 1 or 2 millimetres probably a year, whereas some fast growing food spoilage things can get bigger than that in 2 or 3 days. But it's the same idea. They grow outwards and they use up the algae at the edge as they expand, and you form these neat circles, and this one characteristically dies in the middle, and this is a very good way of indicating what species is involved. Just how stones are leaning can be an important factor as well in what species occur. And this one is quite interesting here, this bright lemony green one, and it picks out some of the letters here because it doesn't like getting wet, and the stone is actually sloping, so when it rains the rain actually misses it and it stays in the dry. So very, very special habitat, and you'll see this doesn't have a lot of the other coloured lichens that you get on the more vertical stones where they do actually get direct rain. So some lichens are very fussy about where they live, and some can tolerate very high amounts of heavy metals, and heavy metal content in them can be used to map where pollution falls out from heavy metals. But one thing they don't like is copper, and while most of the surfaces are covered with lichens when they get a bit old, if you have a look at the top of the tower there, you'll see there's some very clean looking tiles, and this will be because of the copper compounds are coming out of something that is probably brass or whatever at the top and running down and making sure that nothing will actually grow there. And the responses to pollutants are quite important. They were very good indicators of sulfur dioxide pollution, and nowadays when you get a lot of certain lichens, as we have actually on the tree here, the orange lichens, these are indicators that you've got nitrogen pollution issues. So this is another aspect of why these things are worth looking at. If you have a granite tombstone, you have a different assemblage as well. Granites are very hard, so it's rather specialised lichens that are able to grow on them. They're also relatively acid compared with some of the other sandstones, but it means that on the surface you get lichens growing that can come off. This is a typical leafy lichen, and you'll see you can scrape it off easily with your fingernail because it doesn't actually grow into the rock at all. It's actually just attached loosely to the surface by little fungal threads underneath. You can see some of the lichens that are very tolerant of, and in fact will only grow where there's a certain amount of nitrogen pollution. On these branches here, these orange lichens, and these used to be quite scarce in many parts of lowland Britain. They've expanded a lot as the nitrogen pollution problem has become more important. It's important also to remember that lichens do occur on lots of different surfaces. We've been thinking about tombstones particularly so far today, but they will also grow on trees, on rocks, metal, anything. They want a surface to grow on. If the surface is the right sort of chemistry, and it doesn't include copper, they will find something that they can occur on. And many different species occur on trees from the stone surfaces. Some will grow on both. And one of the interesting things here with the churches and yard, and it being recorded for a long time, that there are something like 30 species of lichens that were found here in the past that used to occur on elms. And so there were nice long old elm trees down the side here, and until the mid-1970s, when the Dutch elm disease fungus took them out. You can probably see that these stones look different in the coloured patches on them. This is because they're made of different kinds of stone, sandstones and limestones here, and people that pay for gravestones, for headstones, are very sympathetic towards lichens because they choose different rock types, and these support different species. And there are very little overlap in the species that occur on the more calcium-rich limestone tombstones as opposed to the sandstones. For example, these orange circles here, the Caloplaca here, Caloplaca flavescens, doesn't occur at all on the ones here, and the same grey ones that we have here. These things here we don't have on the tombstone here, and this means that we can get extra species are able to occur in a site if you have a bigger range of rock types that are used to make the memorials to people. So I mentioned earlier that lichens grow very slowly, often just 1 or 2 millimetres a year, and they will tend to form really nice circular patches unless they come against another lichen. So this is a very interesting stone here which illustrates a number of points. You'll see that some of the colonies are really quite nice little almost circular patches, and people look at the growth rates of some of these, and you can use these to help date how long a surface has been there to get a minimum date. It won't tell you how old something has been, but you know that surface has been exposed and the lichen's been able to grow there for so many years. And in Britain there are cases where this has been looked at in some detail, and some particular lichens can certainly last up to about 300 years. Much longer times have been claimed for some in Greenland, but these seem to be due to lichens flowing together. So if people say these exist for 4,000, 5,000 years, don't believe them. But this isn't all peaceful, because where some lichens meet, there's war in the world of lichens that you probably never thought of. The tombstone looks very peaceful, but if you look at it closely here, you'll see that these are coming to stop each other, and some other ones here, they grow around them, and in some cases they will grow over them. So these interfaces are really quite interesting to study, because some will actually meet and coalesce and make one big lichen, so you think it's a single structure if they're the same species. In other cases they will form barriers and stop all growth. In some cases they will grow round little particular ones to avoid them, because they can't overgrow them. And it's on the oldest stones that you get the crustose lichens dominating like this, because they grow much more slowly than the ones that grow more superficial, the more leafy lichens that are only attached to the surface very lightly, whereas they grow into the rock itself. And this means that they can undercut the other lichens and get rid of them off the surface. So if there are some foliose leafy lichens here that were there originally that would have been early colonizers, they'll have been eliminated as these crusts grow under them and take them out of the equation. So there's a lot going on when you actually look at the surface. It looks all peaceful and quiet, and you think it's all going on, but there's warfare there, but it may be taking place over centuries. A very long battle indeed. There's a big debate and concern sometimes about whether the lichens on the surface of the stones actually cause any problems. And like many things in biology, there's no simple answer, because it depends on the stone and the lichens involved. And this is what happens with some lichens, is that they grow into the surface, as I explained, but then as they wet and dry, they will expand and contract, and this can loosen the surface, particularly of sandstones. And there's an example here where this is happening. You see it's peeling away from the surface with a bit of the stone behind it. So the general advice is to not do anything to the tombstones if you've got lichens, but just enjoy the life that's on them.
Thank you very much, David, for that introduction to lichens in Mickleham churchyard. I suppose one of the things about Heritage Open Days that we appreciate most is the fact that a lot of us look at places or buildings, but we maybe not give them a great deal of attention or realise their significance. And I think what David has done today, as far as lichen is concerned, is to make us a little bit more understanding of the role that lichen play in the biodiversity of the world around us, and to make us appreciate something that we see quite a lot of, but maybe don't give a second thought. If you are interested in finding out more about churchyard lichens, a very good guide is produced by the Field Studies Council, and that is available from the Field Studies Centre at Juniper Hall in Mickleham.